that we've learned some shortcuts to find derivatives, let's use those to solve a couple of problems. So rather than using the limit definition, we're going to use the fact that when you have the expression y equals x to the n, when you have an exponent, the derivative is always n x to the n minus 1. So if I want to find the derivative of 5 over x to the fourth minus 5x to the fourth, I'm going to rewrite each term, specifically the first term, as x to a power. 5 over x to the fourth becomes 5x to the negative fourth. Now I can use this power rule that I have circled in green. I bring the exponents down. 5 times minus 4 is minus 20, and then I subtract 1 from the exponent. Minus 4 minus 1 is minus 5. Same thing for the second term. Bring the 4 down. 5 times 4 is 20, and then subtract 1 from the exponent. 4 minus 1 is 3. Finally, I typically ask for answers with positive exponents, so I'm going to take that x to the negative 5 and move it to the bottom. We can do the same thing for the second function. I'm going to rewrite this function using exponents. It becomes y equals x to the 1/2 plus 7. Now I can use my power rule. I bring the 1/2 down. 1/2 minus 1 is negative 1/2. We also learned that when we have a constant, the slope, or the derivative of a constant, is 0. So the 7 disappears. If I want you to write this using positive exponents, you're going to bring the x to the 1/2 to the bottom. So your answer is 1 over 2 x to the 1/2. You can also write that as 1 over 2 square roots of x. Now let's solve an application. Assume that the demand function of an item is p equals 16 minus 1.25 q. P is price per item, and q is number of items sold. Find the marginal revenue, so marginal means derivative of revenue when q equals 2,000 items. Revenue is always price per item times number of items sold. We're given an equation for price, for P, so I'm going to multiply that by Q to get a revenue equation. That means my revenue is 16Q minus 1.25 Q squared. To find marginal revenue, I have to take the derivative. 16Q turns into a 16. The slope of 16Q is just 16. Second term, I bring the 2 down. That's where the 2.5 comes from. And then 2 minus 1 is 1, so I'm left with 16 minus 2.5Q. If I plug 2,000 in, I'm left with negative 4,984. Now the problem has asked me to interpret the marginal revenue. So the units would be, let's see, revenue is in dollars and Q is in items. So this is dollars per item. This is telling me how the revenue will change when I increase production. In other words, when I'm producing 2,000 items, if I choose to increase production, my revenue is actually going to go down by quite a bit. It'll go down by nearly $5,000 for each additional item I produce.